Hey, my name is Aaron Boyd, and I'm going to present the Reiki tube experimentation we did as part of AE 2610. So what's a Reiki tube? It's a long tube that has air flowing into the bottom and then coming out the top with like a heat source about a quarter of the way from the bottom. That heat source with the air flowing in and coming back out causes like oscillations in the heat intensity, which will cause like pressure oscillations, which cause velocity oscillations for like the airflow. That whole action is like a pulse combustor, and those things like feed into each other to cause like a resonance where it gets like more and more intense until the like oscillations being released through the walls of the tube or whatever reach causes it to reach an acoustic balance where it's just like a nice loud noise and it just like stays at that for a good long while. The sine wave, as it were, of the pressure has its nodes at the ends of the tube, whereas the sine wave of the velocity flow has its node like dead center of the tube. So they're like 90 degrees out of phase with each other. So like the positive ones, the bottom portion of the Reiki tube will have the waves overlap, and the top are out of sync. That's why you have your flame source down in that bottom section, so that oscillation can occur. What was our experimental setup? We had a 6-foot steel tube with a propane burner about a quarter of the way up. We had 3 pressure transducers at like bottom area, middle area, top area to record the pressure. We had a photomultiplier to record like the flame intensity, where the flame roughly was. We had a window where we could watch, and then we had a scissor jack that we could use to raise and lower the position of the flame. So we had 5 different tests. We did the flame right at a quarter position with it closed, right at quarter position with like a release valve open so that airflow was interrupted. A quarter of the way with the valve closed, but then also up a little bit, 2 inches, then up even more to the point where like oscillations ceased, and then brought it back down to where oscillations came back. That caused all of these results here. We have the peak sound pressure level in decibels, which was pretty uniform for closed. It was actually pretty uniform for each category. It just kind of went down depending on where the position of the flame was and that sort of thing. But it was relatively consistent across these categories. This was RMS voltage for the photomultiplier for each positions. These were the peak frequencies. It was nice and uniform when it was in resonance, which is what you're looking for. That's like the resonance frequency. That went away when the release valve was opened, and then came back when the release valve was closed again, but then brought up 2 inches. The photomultiplier value was down just because the photomultiplier couldn't see the flame because the flame was out of the way. When we got to 5.25 inches, that was when the resonance went away, so it went back down to essentially 0 frequency. And then it came back when we got to negative 1.3, from minus 1.3 inches from the quarter length position. That brought the resonance back. We also did a manual calculation of the approximate resonance frequency, which was 94 hertz approximately. And then over here was our relative phase angle for like the photomultiplier as well as the upper and lower pressure transducers. Those like demonstrated that that the photomultiplier, the heat release stuff, and the pressure oscillations, that those were about 90 degrees out of phase. It wasn't exactly for the first one you see. It's like 106, second one. That was when it wasn't in resonance, so it kind of just like fell apart. Second one was kind of there, not quite. It was like a weird negative 40 degrees for the photomultiplier. Oh, right, that was because it was positioned out of the way, yeah. That fourth one has it, no more oscillations, and then the last one, it came back. Once again, the flame one was a little bit weird just because of the positioning of it, but yeah. Overall, when you got your flame about a quarter from the bottom, that'll cause the resonance to happen, which is what you're looking for. That'll get your nice sound. A pressure release in the side will like prevent resonance because it doesn't have the ability to flow like it's expecting to, so it just kind of does its own thing. The position of the flame doesn't have to be like exact for resonance to happen. There was like a roughly 6-inch range for there, which you know, somewhere around a quarter, but doesn't have to be exact. The phases of the flame and the pressure oscillations are about 90 degrees when it's like right at that spot, but it also varies a little bit depending on like the position of the flame, and also the recording of the photomultiplier was interfered just because we couldn't see where the flame was moving. It was kind of sporadic at times, but yeah, that was our RecuTube experimentation. Thanks for watching.